What we want to talk about today is AI-led software engineering, basically understanding the role of AI in software development. What I would do is, in next 50 minutes or so, I would talk about what advancements AI can actually bring into the entire development process. Also, primarily from the point in time when AI is becoming mainstream due to immersive explosion of Gen AI, right? That's the core theme. Now, in order to understand that and fundamentally establish how developer productivity, this is not working, how it can elevate developer productivity, let's go back in time and understand how SRE was evolved, right? When SRE started, what was the germ behind, and how eventually it established as a medium to be more reliable and scalable in your systems, right? As Ben rightly put it, that it was a function of, or a direct output of, asking software engineers to design an operation function, right? What happened with SRE was they were not talking about a tool for better observability or a process change for better releases, right? They were focused on building principles and laying out a framework which helps you operate better at scale, right? That's what we need to look at, right? Similarly, adapting Gen AI would widen the aperture. We should not, when we are thinking about role of AI in software development, it is not about a particular tool which solves things for you, right, in terms of generation or triaging. Or it is not about a particular model which generates code the fastest. You should look at whole and understand what framework and platform is required. Now, in order to do that, let's first understand what is a perceived role of AI for developers, right? The first building block of that would be primarily three areas where everybody is thinking that, okay, AI should play a role in terms of software development lifecycle, which is productivity, efficiency, and learning. At a 80,000 feet, it makes sense. And if you see, for example, everybody attributed productivity to code generation. Almost every tool which is available, which has infused Gen AI, is talking about faster code generations, right? Which is good, and it makes you productive. But we need to, these are three very broad areas to understand the impact of AI. We have to drill down deeper and totally understand what developers really mean when they talk about productivity, learning, and efficiency, right? And if I drill down on the same survey and understand where AI has already being used versus what is the perceived idea of productivity, learning, and efficiency, right? Most of the developers talk about that code generation is not one of the primary areas they want AI to help. But you would see that more than 80% usage to date available on AI is for code generation, right? The areas which are fairly untapped, right, like testing, commenting, reviewing, all that is not being taken care by tools or the framework which we have today, and developers are more interested in actually AI to take care of that, right? Imagine a developer writing a complex piece of code to solve a business logic, which are at the same time being ensuring that it's low latency, is something which actually gives them value, right? But at the same time, if they have to comment it, make it more reusable for future use, these are the areas they would want AI to come in and help. Because if you would have seen, for a very long time, the SDLC, test coverage, or the documentation of the code, or the architecture diagrams, these are the components which are typically missing for when you are running at scale, right? When you are developing features at a velocity which is unparalleled, you would see there are areas which are neglected. Ideally, the developers are looking that AI should solve for those neglected areas and make software more robust, not necessarily only to generate code and triage, right? Now, in order to do that, how would one look at this, right? It has to be envisioned. So one thing what we have established is a tool or a model would not solve it for you, right? Ideally, organizations and developers have to think it in a pyramid format, that what they would want to achieve in terms of making AI more mainstream in software development and in general become more productive. The learning should become faster and the process should become efficient, right? The first and the most important building block is the set of models available for you to consume, right? There are first-party models which the likes of Google, Microsoft, OpenAI has, which is open to you in form of a API. What you would see is Gen AI in particular, there's a trend which is emerging. Anything which is becoming mainstream as a use case, there are smaller language models which are equally efficient are being developed at an open source capacity, right? So how do I integrate those open source model again in the same platform or same infrastructure, like a CodeStrel, which is a 7B model and generates very good Golang code? Can I integrate that for this particular use case? A very good documentation agent is available at an open source level. Can I use just the GPU and the TPU to enable it in my organization, right? So the first party models, the open source and the third party models all together provided in the same platform or the same underlying infrastructure layer is extremely important for building low latency features to power developers and product managers and DevOps people, right? Now, not everybody in the organization would actually integrate with these models directly, right? Typically, if you see how you develop features as well, not everybody is talking to your databases today, right? There is a layer which is written on top and people are consuming that API as a layer, right? So similarly, what you would have to do is, for example, your Jira developers or people who are writing your CI pipelines or processes would ideally consume it at a platform and an API layer, and you would have to build an orchestration which decides the best course of action. So when I'm writing, let's say, where my expected output is a YAML, I should pick a model which supports YAML generation as control generation, right? If I'm using a Golang library which I have to develop a code, the best suited model is where I should redirect that request, right? So those kind of orchestration and capabilities with decoupled manner is what you have to expose at the platform and the API layer. Finally, your mainstream developers, product managers, your DevOps people or your QA people would not for every process consume these APIs, right? For them, we need to build those applications. And that applications go beyond like a code generation tool, right? Which is available at your IDE. How do you infuse it at a PR generation level? How would you infuse it when somebody's writing those test cases, right? Where you would actually, it's a baked in feature and it's more like a plugin for them, not like a new development, right? So that also is equally important. Once you have all the internal development activities, once you have exposed a API and a platform layer, anybody who's consuming applications for SDLC should have baked in plugins or features or tools there, right? So this is how an ideal application or ideal AI framework would look like for SDLC, right? Where you pick at everything. Now, if I draw a parallel on your entire cycle, right? There are specific areas where you can actually use these tools and features, right? For example, a very interactive, context-driven chatbot for your software engineers, so that they start, okay, I'm developing this library or this feature, where's my PR, right? When was it last updated? Is the latest updated PR I'm looking when I'm developing the features, right? These kind of questions. It's not just the technology question, but it also retains the organizational context for better answering, right? Then you took at a lot of refactoring and maintenance work, which eventually becomes large tech debts in organization. How do I do that? How do I cater to that, right? Migrating from a previous version to a newer version. Migrating from a platform or a programming language to another one, right? Those are another areas where you see that developers do not want to particularly invest time. Can AI help us there, right? Then talking about triaging in production, right? Faster time to resolution is one of the most important business critical metric. Can AI start helping there? Right now what happens is there are playbooks which are maintained, there are SOPs which are maintained, then there are L1 engineers, L2 engineers. Everybody, if you would see over a period of time, are focused on the institutional knowledge they have built. So that's why you would see that if I have a a team of 10 people, not everybody's mean time to resolution is same, right? It depends on their involvement in the system, their duration, their current understanding, the time differs. What AI can help you achieve is make all of your engineers work at your highest engineer's capacity, right? By incorporating those workflows in a way that it reflects all the best practices you typically want an engineer to adhere to, right? Then finally, once a piece of software is developed, the journey to production or path to production also is a complicated journey, right? Where there are a lot of code reviews, where there are a lot of automation test cases, there are a lot of functional test cases. How do I make AI infused in those areas and make the journey smoother? If my shipping velocity on the first check-in of the feature is 5 days, can I make it 3? Can I make it 4? Right? And it's extremely important to understand it in that context, right? The initial, I have read a lot of news, I'm sure everybody has, that okay, the moment this generation tools are there, we don't need developers, we don't need QA people, or we don't need this. Idea is never that, right? Technology is an enabler, right? So what you do is, you still do with the same number of people, but you ship more, you develop more, you develop better, right? You scale better. Eventually, the price is optimizing your run cost, not people cost, right? So if, let's say, your per request was X dollars, can I make it 0.9x by use of AI, right? That is what AI is becoming extremely efficient and crucial for. Now, we were talking about SDLC, right? And the important aspect which people need to understand is, it goes beyond IDs and your native toolings, right? There are a lot of tools which are not in the critical path of a software development. For example, your test case repo, right? Or once the code actually leaves GitHub, there are 9 to 10 tools which it actually encounters before it goes to production. When somebody has first thought of that feature, from that to actually consumer using it, how many tools are you communicating on an everyday basis, right? Basis on that, you have to figure out how the AI platform layer, which we discussed, gets integrated to, right? How would you integrate to, let's say, Jira? How would you integrate to a code search repo? How would you integrate to your own testing? And that's why an agnostic platform is necessary, right? If you see, if I'm talking or focusing too much on tools, you would eventually see that every tool is solving for a set of services, right? So a tool which supports Git is solving for GitHub. A tool which supports GitLab is solving for GitLab, and so on, right? It's good in certain areas, but if I am trying to build a unified agnostic journeys for organizations, not everybody only uses third-party and open source tools. Interestingly, like I talk to a lot of digital natives and also some AI native enterprises, we see that over a period of years, they have found that they actually run their own shadow IT with a lot of homegrown tools, which serves their purpose at a very cost efficient manner and cover entire thing which the existing tools cannot, right? But if I'm talking about being truly productive, I should be able to integrate it to my existing third-party or open source or homegrown tools, right? That's what you need to see when you're talking about a developer product or a developer platform. So in summing up, right, what our vision for AI-led software engineering is that your developers or your engineers, the experience should also they should feel about, think about, and value their work, right? Which we were talking about just a while back, that when somebody actually solves a very complex problem by writing a piece of code, they feel value, right? Because that's work. But somebody migrated, let's say, a Python old version to a new version, that's not a very valuable thing for developers and engineers, right? So feel and identify the areas which developers value and make them invest more time there, and the rest of the hygiene is what we should make AI driven, right? That's the fundamental idea of thinking of a role of AI in software development. Now, the vision is what we painted, right? But the extremely important step is to start slow. If you start with, let's say, I want to build something which looks like the platform I just said it, and then I would start rolling it out to my individual developers, product managers, and engineers, typically, these would be then the projects which are science projects and you'll never see light of the day, right? So think from agile development product methodology, right? Every sprint, end of the every sprint, you have a shippable feature which people can use. That's how your AI involvement or AI infusion strategy should also work. Divide the entire vision, create smaller projects or smaller achievements. For example, putting documentation for a Git repo for this project, right, or this team becomes a good starting point. But always remember your vision. Your vision is to actually have an agnostic platform. And with every project or every small task you pick, it should eventually contribute to your platform, right? And over a period of time, you would see that with 10 or 20 projects live, you also have your platform pretty much in place, and then you're only finishing the remaining pieces, right? That's what it is important. So everybody should ideally identify one area which they want to work on, right? And not start from, okay, that means like I will evaluate 200 code generation models available, I'll pick the best suite. That's not something which you should start, because that will not reward the entire organization and the teams, right? Now, we understood the platform and we understood that there are capabilities which can be built. Let's see how an ideal journey would be once AI is infused in your SDLC lifecycle, right? Somebody like a PM thinks about, okay, I want to develop this feature, like a faster checkout is what they want to build. Now, they would first use AI to write that feature. This AI is not just writing the feature, this AI is also recommending based on real world knowledge now, right? It will tell that, okay, faster checkout, typically these are the matrices which people have been looked at. These are some case studies where people like Amazons of the world or Googles of the world have published, where they're saying that they have reduced the checkout experience by X percentage, right? Things like that. So then a success criteria, the feature and everything is created. Then it actually goes, those PR documents goes to the developer and the architecture team, right? They not only create architecture, but they actually use AI to decode the features, right? A lot of business terms into technical terms is something which they would have to comprehend in general, right? Like a good principal architect would understand faster checkout means if I have 9 ancillary services, what should be my P95, right? Those kind of attributes is what then AI is the companion for that architect and that developers, right? Then the quick starts, the boilerplates, the set of technologies which needs to be used, all that is what AI is helping through the process to the teams, right? Now, once, let's say, the first level pilot is ready or the first level feature cut is ready for test, it actually then passed on to the QA engineers and the DevOps people. They start generating those artifacts which is required to make it shippable. And also, they would actually start writing test cases, coverage. And the good part is, because same AI framework or platform is interacting with all of these, there are a lot of context which get retained. So once, let's say, a test piece is ready, a product manager can review and see that, okay, what was my interaction with the AI when I was thinking about the feature, how close the coverage is, right? Those kind of things which typically lost in translation if you would have seen in typical, at a scale, when you're shipping at a very high scale, typically some of those things gets lost, right? So with an AI framework which retains context, it helps you there. Then finally, once this is tested, you're trying to write like a PR FAQ, right? What this feature is all about, or what should be my signal to support, how do they resolve it, what are some catch areas which I've not seen, what components I'm load testing on it. Everywhere you're actually using AI, right? And finally, once you're done, there has to be matrix in terms of analysis, right? Faster checkout is one, but ultimate business goal could be increasing an average order value or increasing the number of orders, right? Give the initial picture to your analyst, and then let the analyst use AI to generate better matrices in real time, right? Okay, this is the data I've seen, this is where it is working, this is where it is not working. Now, it's not just about using it elsewhere or telling what an ideal philosophy could be. Within Google, we do dog food, right? So pretty much all the first-party models which right now has the capability of code generation has been in testing within Google for a while, right? So 6 billion lines of code is what we have generated so far just by using AI tools, right? And as we were talking about it, we not only have it at a place which is development or generation or triaging, right? Our code collaboration tools, the journey starts with PR FAQ, right? When you're writing those PRs or FAQs, we have those AI tools baked in our process, right? And similarly, we are exposing that as well, right? So Workspace now have an AI assistant which actually helps you with writing PR FAQs and things like that. So the entire journey is what we have within Google. We are trying to recommend that best practices as part of the AI product suite what we are building, and also putting out the best practices what you can do, right? Like going back to the SRE example, when we started publishing books and papers about SRE, we were not only exposing tools, right? That you use cloud logging, we have services which actually have SLO, SLAs you can define. It's not just that. We actually created practices which you can leverage and customize based for your organization, right? That's where the entire conversation is. We have tools, we have services, but we also have like a framework which we are talking about and which you can use for your AI companion journey, right? Now, all that sounds, I know, like intuitive, easy. What are some fundamental potential challenges when you do that, right? Like, there is a lot of things which we spoke about. Imagine the entire SDLC journey which we spoke about, and using AI in every possible intervention by a human, right? Now, there are challenges, right? LLMs has their own set of challenges, but beyond using LLM, there are fundamental challenges in terms of creating a platform like that, right? These are the basic 6 challenges, and enterprise readiness becomes a fundamental block of it. I would try and show you some demos on how Google is resolving it first, and what are these challenges about, right? So first is repeat. You have to understand, like, let's say your platform gives the capability of writing functional test cases for a feature. Typically, if you see, people are creating features based on two pieces of information. One, the PR doc which a product manager has written, and developer gives release notes, right? But we all know that's not enough. The fundamental block which should be used ideally to write functional test cases is the piece of code which is written, right? Now, I am like a QA or an SDET. My task is to generate a piece of test cases for a new repo which is written. It will not be like a single turn, right? I ask AI, okay, generate 200 test cases, it will generate. It is an iterative process, right? And there will be at least, let's say, 10 or 15 conversations for me to get to an ideal state of test cases. Now, for every time, I would actually need to refer the entire repo. Let's say that is 5,000 lines of code. When I do that, imagine LLM cannot retain that as a memory, right? It actually has their own context window, and you can't go beyond it. So how one manages this repeat conversation, right? So I'll just show what we have, what we do at Google, right? And the same thing is now we've exposed. So we have something which is called as context caching. So every LLM typically maintains something which is called as KV cache, right? Which is LLM's own memory. Typically, pretty much every LLM keeps that KV cache only for maintaining their own context. What Google has done is, we expose that KV cache for you to use, right? So if I see at this demo, what I've done is, there's a service called Vertex AI Model Garden. It has like 9 or 10 detailed documentation written, right? I have pretty much used that entire document set as cache, so that I can now have conversation on any feature in Model Garden, right? Now, if you see this, I am calling one without context, one with context, right? So both of them has different, this is the query with context because I'm giving the cache ID. This is query without context, where I'm just using the data, right? And what you would see is, and the simple question was, what are the text embedding models Google has? It gives me a list of models. Let's do a quick performance check, right? So if you see, 87 seconds is what the model took when I was talking without the session context. It actually took 52 seconds, right? So a fundamental 40% improvement in this kind of a conversation. And why is it important also? I'll tell you, like when we are doing this repeat conversation, there could be two types of conversations, right? One, where a human is talking to AI, which is, let's say, generating test cases in a simple workflow where we are using a chatbot. There, typical cognitive load is 15 to 30 seconds, right? That is something, is a decent enough time for wait, because you get an answer, you read through it, you understand it, and by the time you ask the next question or answer, which may or may not be manageable with the kind of models. But imagine when you have created this as a workflow, there are 9 steps or 8 steps which usually a SDET takes before creating functional test cases. Now that workflow is what AI is doing, where ultimately LLMs are talking to LLMs, right? And they don't need that cognitive time. So they don't have to wait for 15 seconds to receive the entire answer for asking the next question, right? That communication has to be frequent. And also, there is a fundamental time to answer kind of a advantage, right? If you do generating this test cases and ultimately workflows are failing, you're solving the workflow and it takes 6 to 7 hours for you to do it, you would say rather like, I'd still invest some time in the manual, with manual interventions, right? So to automate that, capabilities like caching is extremely important. Now go to second thing, right? If you would have seen, not just now with tools like Figma, Draw.io and everything, not everything is text, right? There are modalities across text, video, images, which is part of your software stack, right? Architecture diagrams, which has to be interpreted. Third-party API contracts, which are in an image format. There could be multiple things, right? So can I basically process all that information with the same semantic space? Typically, most of the LLMs, what they have is, they still process multiple things in let's say, in the same LLM call, but they have their learning space and semantic space categorically differentiated out, right? So they have a text space, they have an image space, they have a video people do not have, but whenever that happens, right? What we understood is, especially for pieces like software development or voice conversations, having different semantic space may not work, right? A simple example could be, I have drawn like a GCS and a BigQuery in an image, and I'm asking that, okay, all my data, it's not a data warehouse, but it's a data lake, and my BQ will talk to my GCS. It's in an image, right? At the same time, the text says delta format is what I'm trying to use, or iceberg is what the POC should be about. These two informations are directly related for you to take a call, right? And that's why they has to be processed together, right? So what we've done is, our Gemini model is natively multimodal, and it processes everything in the same semantic space. So if you see, I've used an image, I'm asking the same model to give me the exact description of what this image is about. So this image, what I've used, is basically tell what an RAG architecture could look on Google Cloud, right? Now, going to third part, verifiable sources, right? So LLM and hallucinations go hand in hand, right? Which everybody's thought that, okay, do not integrate anything and LLM will solve everything for you. Eventually, people understand that LLM cannot say no until specifically asked, right? So it try and creates information which looks real or sounds real, but they are not. Can I give like a fact checker or a source to be integrated to LLM where it actually does that every time it's creating an answer? And that has to be both internal and external. What's what we also understood, right? Like the entire Google search is that people are looking for verifiable information. Can we do that when we are actually exposing LLM for it, right? So I'll just show you that as well. Like what we've done is, we have built something which is called as grounding. That grounding gives you the capability of integrating Google or portals like Stack Overflow or your own repository. So every time LLM is trying to create an answer, it generates its own context in real time. So just an example, if I scroll down here, I've asked for like a common error I'm getting, right? This is an error I got in my application. And this would mean very different in depending on what my context is, right? And I've just like used Google search as a tool here. It tells me that, okay, when you're doing reasoning engine, this is a potential problem. I'm just asking this, I should use input as a variable and it solves the problem, right? If you try the same thing without let's say grounding, and maybe other LLM models or even Gemini, it's not trained with these newer nuances, right? What will happen is it will start creating answers which are very generic on a 400 error. Now, going to the second part, right, which we kind of covered, that time to answer is extremely important. And what you've seen is that when agent and agent are communicating, typically on an average, you would want 300 tokens per second should be processed so that the entire workflow is in the range which makes sense, right? Both programmatically, mathematically, and cost-wise, right? So that's why it's important to build the underlying layer which we were talking in our pyramid, that the last layer, which is infrastructure and model. It's important for you to integrate pretty much everything which makes sense for this kind of workflows, right? So models which are giving you like a 300 tokens per second kind of a limit, but without altering the performance. Because what happened is when people understood that LLM is useful, everybody started with the first order was create a SLM which does part of the job, right? Like 7 billion models, 8 billion models were there. What people understood is it works very well for lesser complex tasks like summarization, or creating a essay on a particular topic, or looking from information and answering some basic static questions, which were good, right? Which is like 20-30% of your use cases. But in software development, the code also has its own semantic. And then what you have to do is you have to understand in depth how a large model or a large language model would do. Now, in order to do that, there has to be a capability that my model either becomes smaller or the inference becomes faster without compromising on the quality significantly, right? So there's a paper which Google released which is called Metformer that precisely does that, right? It gives you a capability where you take a very, very large model, let's say a 400 billion parameter model, and condense it as much as possible with very differential degradation in performance, right? The same thing, it is based on Matryoshka learning, where we also say that with embeddings, right? The semantic information gets retained as much as possible while reducing the dimension. That's the same principle with which Metformer has been introduced. And the Gemini model is a Metformer model. That's why if you would see, Flash is significantly smaller than the 1.5 Pro and Ultra models, but the performance the performance numbers are more or less same, right? And that's what the idea is, right? Another way with which you can achieve the same thing with an SLM is by a concept called distillation, right? Where you take a teacher model which is very good at something, and then you create a student model and teach as much as you can, right? Or you fine-tune the model for a particular domain. So these are some criteria which you look at when you're building your underlying layer of models, APIs, and open source. List down the areas what you want AI to help in, and figure out what POCs you need to do in order to identify these things, right? Like, it should be fast, or it should be domain specific, or it should be trainable or teachable, right? Now, going to large context, right? So so typically most of the models available, 128K tokens is the context, which typically means every token is 4 characters in English. Depending on the language, it may alter. What happens beyond that, right? People started building sophisticated systems to handle all that capacity or memory and everything. But that doesn't give you the performance when you're building a feature like, let's say, a code migrator or unit test generator. These kind of things, like when you want to do it with code, you have very large repos, right? Typically 100,000, 200,000 lines of code, and it can go to multiple levels. What would really benefit if underlying model actually supports that kind of context window, right? So Gemini, both Flash and Pro, that is what we started with in terms of our code generation also, have 1 million and 2 million context window. And every 1 million context window is like 3 Lord of the Rings, right? Or a 2-hour video. So makes your life easier, right? If you would have seen the demos, like you have like a 2-hour product video which you are trying to use, let's say Kafka or any other things, right? You want to know where exactly they talk about consumers and the challenges consumer facing. You just put that into Gemini. Gemini tells you 17 minutes to 19 minutes is the window which you're looking for, right? And the same thing happens when you give a large piece of code repo and say that, okay, I want to do this, where there are fundamental relations between these code files. I want you to preserve it, right? Now talking about multiple sources. All this, what we said so far, gives you the capability of getting a unified interface for large piece of information. Perfectly fine. But as we were talking about that, let's say the functional use case example, I'm building a functional use case and I need to use two pieces of information in parallel. Information one, which is your PR document. Information two is your code repo. Now, when I actually want a test case to be generated, I want these two information in parallel to be fetched out, process it together and send the answer, not the other way around, right? Where I first look at the PR, get the information, and I do that, I pass on to the next model, it takes the code repo, get back, and things like that, right? So there's something called as parallel function calling, right? This is what the architecture looks like. So, simple framework. What happens is when you ask a question, ideal framework is that it makes first call, it makes understanding, get the response, give back. Second call, get the response, give back. And finally, the response is out, right? Where ideally, if I look at, I wanted that information to be processed together, not individual processed information, and then I'm finding the answer, right? With this, what happens is, model understands, okay, there are two pieces of information which I have to look in parallel. I'll call them, I'll get the information. Once this information is passed to me, then I take an informed decision, right? Which is important for particularly the areas like AI development. Now, enterprise readiness is important. So do understand, right? Whenever you're choosing a model, you're choosing a framework, choosing a tool, there are some criteria. Your code is not being used for further training. All the communications which are happening with Tenet outside your organizations are encrypted. You're ensuring that any personal code which you are using, which you are integrating is in your own Tenet or doing in encrypted vectors. So there are a set of checklists which you have to ensure when you are using these pieces of information, right? Ultimately, every piece of code or every piece of software which is generated for you as an organization is your IP. And it should not happen that in velocity, you're losing some potential important piece of information, right? And it has happened in the past. That's why a fundamental block of enterprise readiness to be established is extremely important. Now, why Google, right? There were so many things we spoke about, and these are the, ultimately, if you see, right, 6 areas where you would need assistance on, right? So it starts with design, then build, then test, deploy, operate, and scale. And we covered about pretty much everything, right? Now, as I was talking about, right, that in Google, we also do dog food. So pretty much all the models we have also tested. But beyond that, if I look at from the perspective of our portfolio, right, we don't provide a tool for a use case, right? We don't give you a baked-in IDE tool which helps you with code generation on certain programming languages. In our entire portfolio, across security, analytics, code generation, databases, we have our, like the code assistant which we built is baked in. So if you're generating a Postgre query on Alloy, or if you're generating a BigQuery query, or if you're using, if you're analyzing, let's say, DDoS logs, all these areas AI can assist. Wayfair did it with us, like 55% improvement, 48% higher unit test coverage, and like there was a positive survey with 60% plus developers. Now, in closing, right, understand what we are saying, which I started also with, right? Human is the center. So the idea is not to say that, okay, I would work with 30% less developers. The idea is always that this same percent of developers would be able to produce 30% more or 30% better, right? So that's what you have to understand. It's an enabler, right? Not an entire solution. And now, how would I start? If you remember, we were talking about that think big, that this is your entire universe, but start small, right? So how do I start? The first idea you can start with is Code Assist, where it actually is like your AI assistant, which is baked in your IDs or baked in Android Studio, Jupyter Notebook, depending on what your persona is, that tool is there, right? And Gemini Code Assist is again covering the persona of all the people involved in SDLC. So we are not just talking about developers generating code, we're talking about data scientists, we're talking about mobile developers, we're talking about test cases, we're also talking about operators, right? So let's say you want to generate a Terraform for a GKE deployment, you can do that, right? Because it's fundamentally trained on operator as a persona also, not just developer. Some example we spoke about, right? Nobody likes to actually just use it for code generation or triaging, right? There are multiple things which you can do. For example, commenting the code, generating new code, right? Generating new features, or like ingesting it in your CI/CD pipeline. Somebody reviews it, somebody reviewed your code, or somebody actually did some analysis and they figured out, okay, how do I integrate it? You can potentially integrate it with your existing source controls, right? And that becomes a process or a part of the feature. These are some new capabilities which we are launching. The first one is Flash. So Flash is our like faster model. We were talking about 300 odd tokens per second. In fact, yesterday we announced Flash, the next version of Flash, which is fundamentally 2.5x better in terms of performance and also have better mathematical and reasoning capabilities typically used for code generation. Full code base awareness. One problem, if you see in terms of code generation tools which we had in the past, because of smaller context window, typically a file or open files are the context, right? But your code is beyond that. So how can I actually make that thing workable? So full code base awareness gives you a capability of the tool looking at, or the code assistant looking at the entire code base and then suggesting your answers. Like multi-file is another feature within that. Code customization. Models are trained, like for example, Google Code Assist is trained on pretty much any public repo which is licensed, right? What happens when you're generating code adhering to your organization structure? You would have your own loggers, you would have a way to call databases, right? So code customizations give you that capability. You bring your repo, we in a way index it, we don't train the model even for you, because what happens is when you fine tune the model, the information is still point in time. What happens when you write new piece of feature, new piece of code, right? So code customization give you the capability that every time there is a check-in, you potentially put that as a context in the code customization layer, right? By just vector. It's more like a semantic search for you. Then transformation, we are giving a natural language capability for transformations. You can still, like, when you're writing code, can you start communicating that with natural language for generating complex things like a DSL? Can we do that within the baked in feature? That is something which we have come up with. This code customization in particular, I wanted to spend like a minute more because it's an important feature for you to understand, because when we are talking about code generation, as you saw in the Stack Overflow survey as well, people were talking about it should not be just vanilla code generation, because that in fact, more often than not, for a seasoned developer, the generated code takes more time to refactor than actually writing their own code, right? Because obviously it has its own training data set. What we can do with here is like, okay, this is my logging repo, this is my data repo, and this is my third-party API repo. Go ahead and index all three. Now you have that pertinent information. Now when I'm generating suggestions, I can just tag that, okay, this is related, the question is related to my logger repo. So once the information is then combined, the model's knowledge along with your writing structure or your writing capability, and then the answer is generated, right? Similarly, it also supports top languages. It also gives you the filter to index code or file or subtree. So we are talking about logging repo. Out of that, let's say we have multiple things, right? Your Golang is a different way of logging versus, let's say, Java. You can actually do those filters as well when you're asking questions, right? And these are real-time metadata filters which we have built. So it's only like for you, it's putting a hashtag or putting a comment, and model understands and do that metadata filtering, right? This is something which we are running, so you can scan and become an innovator. We have like same program is running on the booth lower as well. So if you sign up today and visit the booth with a confirmation of sign up, we are distributing goodies. I would stop here and open for questions. We have roughly around 10 minutes, so feel free to ask questions, and I would be happy to answer.
Hello. Hi, good morning. This is Rohit here.
Hey, Rohit.
You talked about caching actually to maintain context. You talked about KV cache and all. So how large that cache could be? I'll maybe talk more about the caching.
So for example, let's talk about Pro 2 million context window. If I remove 8,000, so it's like it can go up to 1 million, 1.5 million tokens. And that's why I specifically talked about from developer context, the minimum right now is 32K, right? So it's not for use cases which you are building where the token size is very small, right? It's more about chatty applications with higher token size. You can go up to 1 million, but the minimum is 32. So typically, let's say a small repo to a very big repo you can go to.
So this is going to be a temporary cache, right?
It is a temporary cache with your TTL. Consider Redis, but Redis baked in LLM itself. You define your TTL, you define your cache IDs, you can do multiple caches as well. So let's say your repo 1 is a one cache, repo 2 is another cache, and both of them can actually have different IDs, and you can figure out when you want to use which cache, right? Okay. So that entire thing you can do, and obviously you can decide TTL. Default TTL is 60 minutes.
Okay, thank you.
Hi.
Hi.
So how can you use AI for the performance engineering?
Right. So two types of things which I've seen people are already using it. One of them we also use internally. Like example, query performance measurement, right? So what happens is you use the entire schema, set of queries which your people write, right? Because that is an area what you've seen, like the data analyst or product managers are writing queries which they're focused on result, they're not focused on performance, right? Typically those results which are heavily used becomes dashboards, and you would see a lot of compute time goes there. Right? So what you can do is build a pipeline where take a query, give the schema, give an example that, okay, this query could have been written like this, and then give you a bunch of queries. Integrate that via something called as tool calling. LLM has the capability to do let's say you're using Trino, right? Give the LLM a capability to call the Trino with the synthetic data and measure the performance number. And this could ideally be also an iterative flow. It made some changes, call the API, get the results back, and say that, okay, do a reflective agent via LLM as well. So it understands, okay, I made these changes, this looks good. However, I changed the where clause to a clustered index, but it didn't work, right? Let me try this, right? So that's how you can actually build for this. Apart from that, if you see Google Cloud, we have baked in some of these code assist agents as part of your logging as well, right? So if you're seeing a lot of like the overall time, you can give that also as context signal, right? That, okay, this is what my model has found, and this is the code base, what changes I can do. Implementing a singleton pattern is example. One thing like we recently did with a customer, we identified they were not using singleton, a lot of ports being opened. Ultimately, the L7 connections were taking longer time, and we just reduced it, right? So again, a tool might not help, right? But you've built a platform, this will help.
But this is basically for the development of coding, right? You improving the performance of the code and everything. But I'm talking about the performance testing part,
right,
where you are actually doing a load testing and stress testing. Where can you do anything with the AI?
There is something which is upcoming there, right? Where people like JMeter and other people are collaborating, but can't talk about it right now. But there's something in the work, right? Which is tailored to basically improving performance test and also baking it as part of your life cycle. Today it's always an afterthought, right? So
and if anything comes in, it can integrate with the open source tool like JMeter and everything.
Yes. So you have to understand, right? Like when we did all the code assistant tools are fundamentally trained and used GitHub. Everybody is integrated to the IDs they are available. Nobody is trying to create a new universe. Everybody is trying to fit in. Yeah.
Hi, this is Mrityunjay. Yeah.
Hi.
Yeah. So, how about the security part?
That's why I said, right? So the enterprise security layer which we talked about, every tool and every platform should have their own definitions, right? So for example, code assist actually gives you an addendum saying that we don't use your code and we don't traverse your code. When you're doing code customizations, we have our set of encryptions and our set of protocols which we follow. And there's an enterprise readiness format which Google follows, right? There's another part which comes with AI in security. It's not just about being enterprise ready, it's also being responsible. Is it being derogative, right? It is being potentially leaking information. So there has to be like a pipeline built. So within Google, we have two principles. One, which is called responsible AI, which basically ensures that AI is being dealt with responsibility. The second part is enterprise readiness, where encryptions, the policies, the adhere. So for example, we are already in process of certifying some of these models with compliance services, right? So that when you're using it, you are not worrying about like using an LLM, I have to like comply with or certify every use case, right? So those are the things which are already in work. So you would ideally spend some time when you're thinking of a model and choice and look at the security features they already offer.
Yeah, hello. Vikash here from
Hi,
Society
Vikash.
Civil. Yeah, hello.
Hi.
Yeah. So I have two questions and both is a link each other. The first question is on the coding assistant on the SDLC with the GenAI.
Yeah.
You talked about the research paper on the condensing the model, reducing the number of parameters.
Metformer. Huh.
Yeah. So what Google is looking for, like how many billions of parameter could serve the whole SDLC lifecycle?
No, so the, one important thing which I started with, right? A particular model will never solve it for you. Depending on the complexity of the use case and depending on the use case, you'll figure out multiple models. What Metformer is talking about is that when the communication has to be faster, without compromising on the quality significantly, we can have lower parameter models. So for example, let's say a 400 parameter model and 8 billion parameter model should not be like 10% or 20% of the performance, right? 20% of the quality, whereas the performance can actually be like 80% better, right? That's the idea, that make it comparable on the 90% range, but improve the performance by 3x or 4x. That's the idea. It's not like one particular model is suited for the entire SDLC lifecycle. That ideally would not happen.
Hi.
Also, the second question, follow-up question.
Yeah.
So
90
today
more
you
seconds,
have
people. So
assistant,
just,
developer assistant, that is a cloud-based.
Uh-huh.
So do you have something where in plan or pipeline where you have enterprise ready? So these assistant could be deployed on enterprise data center and could be used all the data as you were saying.
Right.
That
So CodeGemma is something which we've open sourced, right? And you pretty much can deploy anywhere, and it helps you generate code. So we are already on the path.
Okay. Thank you.
Yeah. All right. I have like one more question. I think 1
Hi.
minute.
So coming to this business intelligence in Gemini, what you had presented. So when it comes to business intelligence, it can only help with metadata tagging, or it can go one level higher than that to define the metadata or data mining.
Right.
To
So
search the
there's something,
keywords.
right. Very good question, right? So we started with tagging or metadata tagging, or giving you the importance layer. We are investing. There's something called as which is AFE, which is automated feature engineering, which also tells you your priority of your data, right? So you have 100 records or for 500 columns, but these 90 columns are making sense for you, right? So and look at Data Studio or Looker Studio. You will figure out how we are baking in AI in the entire business intelligence world, right? Natural language querying for generating dashboards could be a very easy one. Synthesizing your data, right? Data semantic or the cold start takes a lot of time. We are working towards that space. Understanding which features are important for my, let's say, a model or a dashboard also is another area. So those are the areas we are already working on.
And what about document tagging or the OCR part? How
That was a solved problem. AI does it, like LLMs does it better because you don't need a retraining. But yeah, so we already have like a semantic parser, which is a GenAI enabled parser where you do not have to classify each doc. We do that for you with a fair degree of accuracy.
Thank you.
Yeah. All right, folks. I think we are out of time. So thank you. I'm there. We have a booth there. I'll be there around. So please do ask any questions. Thank you. I hope the session was useful.